Now let's do some more review. So first of all, new A instance of A. What would that be? And by the way, notice that these things don't have explicitly defined constructors, so therefore the constructor is the default constructor, which is also an empty constructor that really does nothing but construct the object. So what would that be? Well, that would be true. What about new A instance of B? That would be false because A does not extend B or have anything like that. Instead, B extends A. What about new A instance of C? Well, that's false for the same reason. New A instance of D? That's true because A implements D. New A instance of E? Well, that's false because B is the one that implements E. A does not implement E. And A does not extend B either, so that doesn't work. What about new B instance of A? Well, that's true, it turns out, because, well, B is basically a subclass of A. B extends A. So therefore, a new B is an instance of A. Next one, new B instance of C. That would be false. A new B instance of D. So this one would actually be true because B extends A, which implements D. A has the properties of D, B has the properties of A, so B automatically has the properties of D. B instance of D is true. What about B instance of E? That's true. B instance of F? That's false for the same reason A instance of E is false. And then, next one, new C instance of A. That's true because C extends B, B extends A. New C instance of D. That's actually true because C extends B, B extends A implements D. So C has the properties of D. C does implement D indirectly. Next one, new A instance of object. That's any of this is always going to be true. Basically, if we have an object instance of an object, that's true. What about new G instance of object? Actually, that would be an error because, well, we can't have new G. That's just invalid. What about, say, new H instance of G? That's true. What about new D instance of object? Well, that's error because we can't have new D again. Because, well, D is an interface. Just like abstract classes, we can't have new interface. What about this? New A instance of string. Well, it turns out this one's actually an error because Java already knows explicitly that it's something of type A in the compilation time can never be a string no matter how hard you try. So therefore, it's false. But like Java knows it's false, so it's like it's pointless to print this thing to begin with. So Java just says it's an error. Note that if you cast A to an object, like cast this thing to an object or something like that, then you can perform that, but it's going to be false. So for example, object O equals new A, and then print O instance of string. That would be allowed because during the compile time, O is an object, and an object could be a string. Now, is something like AA equals new B allowed? Yes, because B extends A. Is something like this allowed? No, because A does not extend B. Is something like This allowed? No, because again, new D is not allowed. Is this allowed? Yes, because A implements D. Is this allowed? Yes, because B extends A and A implements D. Is this allowed? Yes, because C extends B, B extends A, and A implements D. Is this allowed? Again, no. Is this allowed? Yes. Is this allowed? It's allowed to compile, but when I run it, it's going to cause a class cast exception because, well, A cannot be cast to B. Basically, this thing is an A, and it's actually not a B object. It's not an instance of B. And of course, we can avoid stuff like this using the instance of operator. Now, here's an exercise. So first, create an interface named drivable with methods accelerate and break with no return types or parameters. So, interface drivable, and then void accelerate, void break, compile. Yep. And an interface named paintable with methods get color and set color, or get color takes no parameters and returns a string, and set color takes a string and returns nothing. So first paintable. Again, these interfaces, the methods don't, like these abstract methods, again, abstract instance methods don't have anything. Like we don't have to implement them. Drivable, paintable. So, for example, void set color, string C, and void, no, string get color with no parameters. Next thing, create a class named car that implements drivable and paintable. And then car should also have an instance variable color. And let's make this private because we already have get and set methods that we need to implement. And it should also have a constructor that sets color. And let's just say color equals C. And now of course this won't compile because I need first the, so first this thing says set color, string C probably is more suitable. Color equals C. And then of course we need get color, return color, and then we need accelerate and break. So accelerate, so then I print accelerating, and then public void break. We could have a speed variable to indicate this, but for now I'm just gonna do this. Breaking, because this is what the problem statement says. And then create a class named truck that implements drivable and paintable. And then afterward, basically, let's just copy the car class and make it truck this time. And then make this accelerating dangerously like the problem statement asks, and braking dangerously. And of course make the constructor name match. And now finally create a method that takes a drivable object and calls accelerate and brake on that object. So useless method drivable D, and say d.accelerate d.brake. And now let's just useless on new car red. And now accelerating and braking. Useless on new truck red. And now it's accelerating dangerously and braking dangerously. Now let's do some more exercises for some more miscellaneous topics. So first, create a method that prompts the user for two integers, then prints its sum, and if the user inputs improper data, then print invalid input instead. So for this one, again, user input, so import java.util.scanner, or since I'm lazy, I'm putting star, since I might be using other stuff from util later. Then afterward, public static void, say print sum of user input, no parameters, then I create a scanner. Then if the user inputs improper data, print invalid input, and otherwise print the sum. So first of all, int a equals input.nextInt, and b equals input.nextInt, and basically print a plus b. Now first, when I call this method, so print sum of user input, it appears to work. So basically, for example, 5, 7, and also I should probably prompt the user, so print, say enter two integers, and then that works. However, there's problems. What if I don't enter two integers? Like, what if I enter 5.6 and then 7? Or what if I enter like not a number, like ABC? Then what happens? Well, then you see there's an input mismatch exception. So how do I deal with that? Well, I can try and then catch input mismatch exception. You can always get the what type of exception it is from the error message. And then say, for example, print invalid input. So now if I enter 4, 6, it works. If I enter, say, 4.56, invalid input. If I enter ABC, invalid input. And if I enter just like 6, it's gonna wait for another integer. Now, what happens if I try to do this again? Well, it turns out, let's try this again. Enter two integers, 5, 7, enter two integers, 6, 8, it works. Next exercise, create a method that takes a string and returns a string with the first character put at the end. So for this one, it returns stuff, so public string first character at end takes in a string. Now how do I do this? Well, I just return s.substring 1, which is basically everything without the first character, and then I add, say, s.char at 0 or something like that. Remember, you can add primitive data types to strings. So then, therefore, now I print, for example, first character at end of, say, ABC DEF12, which is the input, sample input. I have to make sure this thing is static as well. And then it prints, so if I get rid of these user input things so they don't become annoying, it prints the proper output, BCDEF12A. Here's one last exercise. So consider this following game where we have a circular board where we have 10 positions labeled 0 to 9. We start at position 0. Each turn we roll a die and move that number of squares. And then basically If we land on a non-zero square, our score increases by the number of times we've landed on that square, including the current time. So the first time earns 1 point, second time earns 2 points, third time earns 3 points, and so on. But if we land on 0, we get nothing. We get 20 turns and the game resets. So basically, we have to create a class that simulates the game. So class, let's just say random game. Now, what do we need to keep track of? Well, first, we need to keep track of our position. So current position starts at 0. We need a constructor, but that constructor really doesn't have to do anything so far. We need a method named roll. Public void roll that simulates a turn. So first we need a random that generates that roll. So first of all, we could use math.random or we could use the random class. For this one, I'll just use math.random. So int roll. By the way, we're allowed to have variables the same name as methods because methods are distinguished with parentheses. So int roll equals math.random. Well, that doesn't work. Int of math.random, that's 0. Int of math.random times 6, well, that's 0 to 5. So then I have to plus 1. That's a roll. Then I say, for example, you rolled roll. Then, for example, tells us our old and new positions and old and new scores. You moved from position current position to position current position plus roll %10, something like that. And then our old and new scores. So we need to also keep track of the score. So I print your score increased from, say, score to. So then we need to keep track of how much our score increases by. So the number of times we've landed on the square. So we need an array of size 10 to keep track of that. So basically, from score to, say, ARR of, so I can just say current position plus equals roll current position % equals 10. My score increased from score to ARR of current position plus score. So something like that. And of course, we need to also update the array. So right before I print that, ARR of current position plus plus. And now again, we need our 20th row resets the game after the turn. So if, again, now we need to keep track of the number of turns. So number of turns plus plus, if number of turns equals 20, then I reset everything. So first I can tell them their final score is, and then say the score. Then afterward I can say current position equals 0, score equals 0, ARR equals new int 10, and number of turns equals 0. And now I can simulate this game. So random game R 1 equals new random game. And then now say r1.roll. And let's just say I don't want to program that into the hardcore, like hard code program that. So let's make a static method that runs the game. In fact, let's make a static method that runs the game here inside of our random game class. String s equals input dot next line. If s dot equals quit equals ignore case quit, then say return, then otherwise I continue. So I do random. So first I must create one of these. Random game r equals new random game. And then while true. By the way, return quits out of the method, so we don't need to worry about breaking out of the while loop. Then r.roll. There is no input, so scanner input equals new scanner system.in. And now if I do something like random game dot say run game, then our program works. Press enter or type quit to quit. In fact, it might look better if I put this, say, in the same line. So system.out.print. And now let's comment out everything else so that now this program is exclusively the game. So now press enter or type quit to quit. Enter. Move from position 0 to 6. Score increase from 0 to 1. Quit. I quit. So this thing works. And we notice that our score hasn't really increased. So why is that? It's because I didn't update my score. So score plus equals ARR of current position. Then I get to just print score right here. So that's an example of how I can like see that my program doesn't exactly work, but then I take a look at my code and realize the problem. So quit works. Enter. Enter. My score increased from score to score. That's a problem. So int old score equals score. Then I can say my score increased from old score to score. So now enter, enter, and we're supposed to get nothing if we land on 0. So then therefore, if position not equal to 0, then works. So current position. And now everything works as intended. And after our last turn, their 20th turn, it finally stops and then it resets the game and everything works properly.